Reinterpreting the 1952 Flatwoods event as a dusty plasma discharge, geological battery mechanisms, historical mythogenesis, and strategic implications. White paper draft, for peer review, ResearchGate preprint author, independent researcher July 2026. Abstract. The September 12, 1952 Flatwoods, West Virginia incident is canonically described as a close encounter with an anomalous entity. This paper re-evaluates primary witness reports and local geology through the lens of atmospheric dusty plasma physics, specifically the geoelectric battery model developed for the Hessdalen lights in Norway. Braxton County shares key lithological features with Hessdalen. Quartz-rich sandstones, sulfide ores containing sphalerite, pyrite, chalcopyrite, and siderite, separated by fluvial systems providing acidic electrolytic groundwater from pyrite oxidation. Under dry, dusty conditions, tectonic stress-induced piezoelectricity may trigger sustained ball lightning discharges exhibiting visual, acoustic, olfactory, and particulate characteristics consistent with witness testimony. A historical timeline of Gray Barker and James W. Mosley demonstrates how this plasma event was transformed into foundational UFO lore. The paper hypothesizes that persistence of the extraterrestrial narrative over the geophysical one may relate to strategic value of naturally occurring high-potential geoelectric sites for energy and VLF-based forecasting. Analogous to Oklo natural reactors in Gabon. 1. Introduction. On September 12, 1952, at tilde 1915 Eastern Standard Time, a bright meteor fragmented over West Virginia. Shortly thereafter, 7 witnesses near Flatwoods reported a luminous aerial object and associated tall figure on a hilltop. The event was investigated within days by local writer Gray Barker, who would become a foundational figure in UFO publishing. Contemporary analysis has focused on sociological and extraterrestrial hypotheses. This paper proposes a parsimonious alternative, a sustained low-altitude dusty plasma discharge misidentified by juvenile observers unfamiliar with ball lightning phenomenology. 2. Witness observations reinterpreted as plasma. Visual. Central white-orange core 0.5 to 1.5 meters with optically thick sheath, in fog-Mie scattering creates apparent 10 FT cowl. 2 internal arc channels appear as glowing red eyes. Acoustic. Crackling, hissing corona discharge, 3 to 7 kHz VLF spike emissions as recorded in Hessdalen by emblem emissions. Olfactory, chemical, ozone, nitrogen oxides, ionized sulfur from pyrite dust oxidation. Witnesses reported acrid metallic smell, vomiting, eye irritation for weeks, consistent with plasma chemical exposure. Residue. Fine sand like dust falling. Hessdalen ground retrieval, spheroidal iron microparticles and zirconium silicate fallout from sustained dusty plasma. Solid precipitation is predicted feature of long-lived ball lightning. Kinematics. Gliding, hovering, appearing to fly like craft. Non-ballistic motion along local conductivity gradients, documented up to 19 kilowatts radiant power in Hessdalen, with ejection of secondary green orbs. Figure 3. Reinterpretation, Flatwoods as geoelectric plasma event. 3. Geological cross-reference, Hessdalen versus Flatwoods. 3.1 Hessdalen Valley, Norway, established battery model, literature reports, in the specific Hessdalen area, an electric triggering mechanism above might be produced by the existing high abundance of quartz, copper, and iron underground. When quartz is subjected to tectonic stress, it generates piezoelectricity, while copper is an ideal electricity conductor. Hessdalen sits with quartz-rich rocks and conductive sulfide ore deposits containing iron, zinc, and copper on opposite sides of the river Hesja. Sulfur mines provide sulfuric acid electrolyte, forming a perfect natural battery. VLF surveys map conductive zones as natural current pathways. 3.2 Flatwoods, Braxton County, West Virginia, flat-topped hills capped by deposits of sand, gravel, quartz, and chert boulders. Monongahela and Conemaugh formations, interbedded sandstone, siltstone, red, gray shales, coal with siderite, limestone, vein quartz pebbles, sphalerite, pyrite, kaolinite and barite. Predictive mineralogy for Braxton County lists pyrite and siderite as expected unrecorded species. Pyrite oxidation produces acid mine drainage, functional equivalent to Hessdalen sulfur mines. Elk River, Little Kanawha watershed provides fluvial separation of zinc-lead ridges from copper-bearing shales. Under September 1952 hot, dry, dusty conditions after drought, charge storage in dusty air could not bleed off slowly, building until air breakdown. 4. Historical Mythogenesis timeline. Sept 12–15, 1952, incident. Gray Barker from Riffle, WV interviews witnesses with tape recorder. January 1953, Barker's The Monster and the Saucer, published in Fate magazine. Fall 1953, Barker launches the Saucerian after collapse of Albert Bender's International Flying Saucer Bureau October 1953. 1953–54, James W. Moseley Cross Country UFO Tour, July 1954 co-founds Saucer News. Barker and Moseley maintain public feud later admitted as sales hoax. 1957, Barker and Moseley jointly execute straight letter hoax, forged State Department letter claiming inside UFO knowledge. 1960s, Lost Creek saucer film staged by Barker, Moseley. 1956, Barker publishes They Knew Too Much About Flying Saucers, Inventing Men in Black Mythology from Misreported Air Force Investigators at Flatwoods. This sequence shows transformation of localized geophysical event into foundational UFO culture by two admitted hoaxers. 5. Strategic implications. Why the plasma model was not pursued. This section is speculative and presented for discussion. If Hessdalen and Flatwoods represent naturally occurring, geographically fixed high-potential geoelectric transformers, three strategic applications emerge. A. Center tappable energy. A repeatable 19 kilowatts plus atmospheric discharge implies subsurface potential of megawatts. Mapping such sites would constitute energy resource survey. A valley acting as a natural battery is a strategic resource. B. Seismic, VLF forecasting. Piezoelectric precursors to earthquakes generate identical VLF signatures to those recorded before Hessdalen lights. Studying lights provides proxy for earthquake prediction technology, capability with military value for monitoring underground nuclear tests. C. The Oklo analogy. Discovery in 1972 of 16 natural nuclear fission reactors operating 2 billion years ago at Oklo, Gabon, demonstrated geology can create functional reactor without human engineering. The Oklo reactors operated via groundwater moderation of uranium deposits. A natural geoelectric battery is less exotic than natural reactor but carries similar classification incentive. Disclosure of specific valleys as natural power sources would invite resource competition. In this context, allowing public narrative to remain focused on extraterrestrial visitation rather than geophysics would be operationally advantageous. Discredits witnesses, diverts amateur investigation away from soil sampling and VLF, magnetometer deployment, and avoids public discussion of energy and forecasting applications. 6. Testable predictions. 1. VLF-EM survey in Braxton County should reveal conductive zones with river-separated conductivity asymmetry. 2. Soil from 1952 hilltop should contain iron microspherules and elevated quartz, pyrite dust similar to Hessdalen landing sites. 3. Reanalysis of Project Blue Book Flatwoods file versus WVGES mineral maps should show correlation between sightings and pyrite quartz outcrops. 4. Laboratory dusty plasma experiments with Braxton County soil simulant under piezoelectric impulse should produce sustained orange-white orbs with green envelope. 7. Conclusion. The Flatwoods entity is parsimoniously explained as sustained dusty plasma discharge fueled by quartz piezoelectric, sulfide battery geology under dry conditions. The cultural narrative was constructed by Barker and Moseley. Persistence of extraterrestrial explanation over geophysical one may reflect both cultural preference and strategic disincentive to publicize geoelectric anomaly sites. Further instrumented fieldwork in Braxton County using Hessdalen automatic measurement station methodology is recommended. References. 1. IFL Science Piezoelectricity, or a natural battery. Hestilin lights. 2. Hangar 1 Publishing, Project Hestilin, 40-year scientific quest, quartz and sulfide deposits opposite sides of river. 3. WVGES, mindat.org, Braxton County Predictive Mineralogy, Pyrite, Siderite, Sphalerite. 4. USGS, Distribution of Arsenic, Selenium, and Trace Elements in High Pyrite Appalachian Coals. 5. Oklo Natural Reactors, Gabon, Nature's Nuclear Reactors, Scientific American, Wikipedia. 6. Gray Barker Collection, Clarksburg Harrison Public Library, Timeline. 7. History.com, in 1952, Flatwoods monster terrified 6 kids, a mom, a dog, and the nation. 8. Turner, D. Electrochemical Plasma with Aerosols Model for Hestilin.